Hey guys! So I'm going to do a couple proofs so that you guys have something to kind of listen to and watch before your big quiz tomorrow. So the first one I'm going to go over is from worksheet 5. It's number 18, very similar to what you might see tomorrow. So first I'm going to take a look at my givens. I'm given that SV bisects angle TVB. So the first thing I'm thinking of is, what does that tell me? I'm noticing that SV is bisecting an angle, okay? So since it's bisecting an angle, and specifically it's going to be this angle right here, TVB, that's this angle right here. So what does that mean? That means that this angle is going to be cut in half. So it's not going to be congruent segments that comes from that, it's going to be congruent angles. It's going to be these smaller angles here. So I'm going to number these. I'm going to zoom in a little bit. Let's number these 1 and 2 just to make our lives a little bit easier. 1 and 2. All right, and let's go ahead and start our proof. Just starting with the first given. All right. So we know SV bisects angle TVB. And that's my given. So what does that tell me? That's going to tell me that I have two congruent angles because the angle's being cut in half. So that's going to tell me that angles 1 and 2, the ones I just numbered, are congruent. And the reason for that is just the definition of bisect. Okay, if an angle is bisected, it's cut into two congruent parts. That's just the definition of bisect. Perfect. All right, so we're done with our first given. Remember, guys, every time with this, we're just looking at our givens and deciding, what does that tell me? Second given, look at that, what does it tell me? And once I run out of givens, what do? I start looking at the picture. Do I have vertical angles? Do I have a reflexive side? And so on. So let's go ahead and take a look at our second given. SV, that same middle segment, is going to bisect angle TSB. So again, I'm going to have congruent angles. Since my angle is being cut in half, angles will be congruent. Which angle is it this time? TSB is this angle back here. So again, I'm going to have congruent angles. It's going to be these ones. These ones are being cut in half. And again, I'm going to number these angles. Let's number them 3 and 4. Perfect. All right, so what does that second given tell me? It's going to tell me that angles 3 and 4 are congruent. Those angles are being cut in half. So let's go ahead and write down my given. SV bisects angle TSB. And again, that's given. And what does my given tell me? It tells me those angles are going to be congruent. So angle 3 is congruent to angle 4. And same reason as number 2. Definition of bisect. All right. So looking at this, I've now run out of givens. I've used both of my givens, and I'm wondering, where do I go next? So I need to look at my picture. Looking at my picture, I can see a reflexive side. And this is very typical, you guys. Once I run out of givens, I want you guys to look for that reflexive side. SV is obviously going to be congruent to itself, all right? Once I have that, I hope you guys can see that I'm going to have two congruent triangles once I say that reflexive side. This top triangle is congruent to the bottom triangle. You might be thinking, well, how are they congruent? They are congruent by angle, side, angle. So let's go ahead and finish out this proof. Step 5 is going to be SV is congruent to itself. My reason is the reflexive property. And my final step is going to be to say that the triangles are congruent. TSV is that top triangle, congruent to BSV, the bottom triangle, by angle, side, angle. And again, I've already proved angle, angle, and then a side. And obviously the side is in between the two angles, which is why it's going to be angle, side, angle in that order. So let's finish out this proof. Okay. Triangle TSV congruent to triangle BSV. And my reason. Angle, side, angle. And what were our steps? 2, 4, and 5. So that's the end of the proof. Let me see if I can zoom out. Some of this got a little weird. So there we go, guys. And we'll shrink this guy down. Perfect. There's the proof. All right, moving on to our next proof. The last one I'm going to do on this video. This is number 19. This one is tough, I'm not going to lie. And let's talk about, in terms of your quiz, we're not going to have one necessarily this challenging, but you will have one that is going to use CPCTC, and this proof uses CPCTC and actually a step beyond CPCTC, which won't happen on the quiz, but you guys are definitely going to need to know how to use that theorem, CPCTC. Something else in here is the word trisect, and I think you guys should know what that is, but we're definitely going to want to go through what does that mean in terms of the proof. So my first given is that PG, this guy right here, and PR, this guy right here, trisect angle LPM, which is this top angle. Trisect is very similar to bisect, you guys, but it's just that the three angles are going to be congruent as opposed just to two angles being congruent. Whoops. Okay, so let's see. Here we go. We got three triangles that are going to be three angles that are going to be congruent. I'm going to number them. And we're going to have angle 1 congruent to angle 2, which is congruent to angle 3 because the angle is trisected, cut into 3 parts. I'm going to start the proof out. PG and PR trisect angle LPM. Now, I'm also starting to think about the fact that I'm going to need to use CPCTC, and the reason is because of what I'm trying to prove. Let's talk about this for a second. What am I trying to prove? I'm trying to prove that PGR is isosceles. Let's talk about what that means. PGR is this triangle right here. I'm trying to prove that this triangle is isosceles. What does that mean? What's the definition of isosceles? Two sides are going to be congruent. So those yellow marks are what I'm trying to get. Okay, I'm not quite there yet, so I'm going to erase those. But I'm trying to get that those two sides are congruent. That's the goal here. Once I have those sides congruent, and I'm going to get them congruent using CPCTC, okay, then I can say that the triangle is isosceles because it has two congruent sides. So that's kind of the idea behind this proof. We need to get there by proving two of the triangles congruent. I'm going to try to prove this triangle with the angle 1 congruent to this triangle with the angle 3. Okay, because that way I can say that these sides are going to be congruent. All right, that's the plan of action. Let's go for it. All right, I didn't finish that first part of the proof. I need to say that angles 1 and 2 and 3 are all congruent to each other. It's going to be definition of trisect. Okay, done. My next part, and I'm going to put this in the same step, that PL is perpendicular to LG. PL and LG, so there's going to be a right angle right there. And also that PM is perpendicular to MR. PM, MR. So there's another right angle. So angles L and M are right angles. That's what comes from that given. Angle L and angle M are right angles. If perpendicular, then right angles. All right, cool. So now I've used these givens. Let's talk about how I'm going to prove this. Let's see. You know what? We're going to go ahead and say that those right angles are congruent. Most of the time, you need to actually state that the right angles are congruent. Angle L congruent to angle M. The reason is if right angles, then congruent. Okay. So now, what do I have going on here? I have angles, boom. I have angles again, boom. My last given is that PL is congruent to PM. So this is congruent to this. So now I have my triangles congruent by angle, side, angle. I hope you guys can see that. That's why I had to state that the right angles were congruent, so that I could say angle, side, angle. HL is the only one where technically you don't have to say the right angles are congruent. All right, so there's the side. And I can go on to step 7 to say the triangles are congruent. Triangle PLG is congruent to triangle PMR by angle, side, angle, steps 2, 5, and 6. All right, not quite there. It's kind of hard to see, so I'm going to switch up that color. All right, number 8 is that PG is congruent to PR. Remember, I have to say those sides are congruent first. That's CPCTC. Okay, now that I've said those sides are congruent, I can finally say that this triangle, because it has two congruent sides, PGR, is isosceles. And the reason is that that's the definition of an isosceles triangle. Okay, that it has two congruent sides, which I just proved that there's two congruent sides using CPCTC. Now, there's not going to be anything this extensive where you have to go 2 steps beyond the triangles being congruent, but be prepared to do a CPCTC problem. So, again, those are only 2 of the proofs, but hopefully this is giving you guys an idea of whether or not you're doing them right, if you have the right mindset, if you're starting them right, and so on. If you guys have any further questions, don't hesitate to email me, and good luck studying tonight. I'll see you guys tomorrow.